Class, we're starting the second part of 11.4. On our first part, we constructed probability of rolling a dice, primarily one with 12 sides, but it could be 6, it could be even more. They make dice for games, and they extended the numbers. So now we're going to do probability study of cards, a deck of cards. Now some of you are very familiar and some are not. So if you are not, do not despair. I'm going to instruct on reading cards. First off, there are color here. I was in red. There are 52 cards in a deck. And there are 4 suits. Suits are of a specific symbol attached to them. And they are called hearts, diamond, yes, I'll go with the reds. Let's see, they use clubs, spades, suits. Well, on the 4 suits, there are 12. Add up. I'm sorry, 13. Can't do math. 12 is face cards. I apologize. Add up to 52 cards. Then we have king, jacks, queen, and kings. These are called picture cards, and they're really called face cards. There are 12 total. Aces are not a face card, and there are 4. Well, there are 4 for each of the cards. See one. So this adds up to 52. Now remember, there are 4 jacks, 4 queens, and 4 kings of that, which add up to the 12, so that when I added this up, I got the 52. All right. Now, let's talk about the probability aspect. You are dealt 1 card from a standard deck. Find the probability of being a 7. It being at 7. There's a typo on that. So a probability card is a 7. Right. So our sample space is 52. Our event is the card 7. So we have a 7 of hearts. We have a 7 of diamonds. We have a 7 of clubs. And we have a 7, oops, sorry, I shouldn't have a comma there, because I'm just telling you what the cards are. A 7 of clubs, a 7 of spades. So we have 4 of that event. So we know that it's the cardinality of our event, or the cardinality of our sample space. And that is 4 out of 52. Well, I'm going to divide by 4. I get 4 divided by 4 is 1. 4 divides into 52, 13. So, is it likely or unlikely? Or is it 50-50? Or is it a certainty? Well, this is unlikely. Doesn't mean you can't get it. It's just unlikely that we'll draw it. So here we had find the probability of a face card. Okay. So in this case, our sample still 52. Our face cards, our event, 12. Because on our chart, I showed you it was 12 face cards. 4 jacks, 4 queens, and 4. I'm not going to list all of them, but that's what we have. And so we're going to write our structure. Probability card is a face card. So we know it's a cardinality of our event, cardinality of our sample space. And that was 12 out of 52. Right. So we know we can divide by 4, so we can definitely divide 12 by 4. And we're going to get a 3 over 13. It's still not half, so it's still pretty unlikely. It doesn't mean we won't get it if we draw it, but it's unlikely range. Find the probability of being dealt a card greater than 2 and less than 7. Okay, so sample space for the cards is still 52. And then for our event, I'm going to state that 2 is less than the value of what we want is less than 7. Of 3, 4, 5, and 6. These are the values that are 2 is less than the value and is less than 7. So, because these are the numbers in between, and we have 4. So we're going to have probability of less than the draw is less than 7, and that cardinality of our event, cardinality of our sample space, 4 out of 52. And we already know that's 1 out of 13. I did this wrong. I have to come back. I forgot something. What did I forget, class? And I'm looking at it. Well, there are 4 3s, 4 5s, and 4 6s. Oh my goodness, I forgot that. 16. So let's do it again. And I said, there is a swarm. So it's a cardinality of our event, cardinality of our sample space. 16 over 52. Well, we're going to divide by 4 at least, and then I'm going to get 13. It's still not half, so it is probably unlikely, but it's higher than the one we did. Sorry about that. I'm glad I caught it before I continued. Now we're talking about a coin and a flipping it twice. A fair coin is one coin. It's tossed 2 times. And we know that a coin has a head, or a tail. And then it says the set of equally likely outcomes is head, 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 tail, tail, head, tail, tail. And what we're talking about here is a permutation, kind of. Well, actually, it's a not a permutation. It's a well, if we did, this is our event. If we did a chart, head or a tail for the first draw, well, then we could do what? A head or a tail, or a head or a tail. So this makes it the head, head, tail, head, and tail, tail. And that's where those come from right here. And of course, they don't have a comma in between because they're listing what it is. Find the probability of exactly zero tails. Right, so our sample space, our coin, is 4. And then our event is no tails flipped. Show. Okay, so no tails means this one, and this one are out. No tails. So I only have one. That's the head, head. Does not. It's one. So the probability of our event is the cardinality of our event over the cardinality of our sample space. This is 1/4. Unlikely. Right. Now we're getting to die. A die is a six-sided. So that means that all of the numbers that you can draw are 1 through 6, 1 through 6, and we're doing it twice. So they made this chart of 36 likely outcomes of rolling a die twice. Fair die. So if I roll a 1, 1, I get a 2. If I roll it twice and I get a 1, 2, I get a 3, and so on and so on. And we notice one thing about this guy. There's only 1, 1, and there's only 1, 6, 6, which is 12 and 2. So the numbers run between 2 and 12. And then we notice something interesting, and that is that we can have numbers. Now, the largest possibility is, of course, 7. So they run diagonally. So if I was looking for how many 7s, 1, 2, 3, 4, 5, 6, I'd know it was 6. Well, what about 8? Well, that would be 1 less. 5, 4, 3, 2, and 1. Do you see that? So then we could have, in this case, the largest is 6, 5, 4. This guy for 12. And of course, this runs this way too. To get 6, because these are 8s, to get a 6, we would have the 5, 4, 3, 2, and then the first one is 2. All right, so that's how we read the chart. Find the probability of getting two numbers less than whose sum is 2. So we're looking probability of rolling 2 die, sum. That was interesting because we discussed that. Our sample space is 36. It's only 1, 1, which adds up to 2. and that probability sum is 2 is the cardinality of our event over the sample space, 1 out of 36. Highly unlikely. Now we have this one. Probability of two numbers whose sum is 13. Well, we said our highest is 12 and our lowest is 2. So there is no two dice that rolling with 6 sides that we can get a 13. So we know the answer, but let's structure it so there is no mistaken information. Our sample space is 36. Our event is to roll a 13, and it is 0. So we're going to structure our probability. So it is the cardinality of our event desired over the cardinality of our sample space, 0 over 30. Definitely in that category of impossible. It's our last one for this section. Find the probability of getting numbers whose sum is 36. 6, sorry, not 36. Samples 36. Well, 5 and 1 is 6. 4 and 2 is 6. 3 and 3 is 6. 2 and 4 is 6. And 1 and 5 is 6. So we know that this is 1, 2, 3, 4, 5 events. 6. All right. So let's do the construction. So our sample space is 36. Our event we already highlighted what that was, and the cardinality is 5. Remember we did it. So we want probability sum is 6. And that sample space, and that will make it 5 out of 36. Still in the range of, maybe not likely. Rolling it twice is a little more complicated. There's no certain unless we want to roll any sum between and including. So that's our lesson. It is a very good lesson because we've discussed everything that we need. Right, everybody good? Okay, now we've learned definition of probability, sample space, and we've also applied formula for probability, predict the likelihood desired event. Know that the probability of an event is structured by a cardinality, the count of the desired event over the cardinality of the sample space. Thank you so much for listening. Do your homework. Thank you.